Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Welcome, everybody, to today's episode of Pepperl+Fuchs Plugged In. Today, I have Jerry Pacey with me. Hi, Jerry.
How are you doing, Helga?
I'm doing fine. Thank you, Jerry. So, today's going to be a little different because we're not talking about a specific product, but in a sense, we're talking about a technology. And we want to also limit it a little bit, at least, to the material handling industry.
That's right. Although it's not limited to material handling, it makes sense because I think it's most applicable, and I happen to know the most about that one.
Yeah. So, what is the topic for today, Jerry?
What does IIoT mean to us?
Okay. So, obviously, I got to ask you, what is the message? And very important, I always ask the why question. Why is this of interest to our audience?
Sure. So the idea of IIoT may mean many things to different people, and it's changed over time. So I think in the past, not to give a history lesson, but many years ago, I think only a certain amount or type of person understood what it was when IBM kind of coined that topic of IIoT and the Internet of Things. Fast forward to today, where people have a Blink camera in their home, or they have, sensors at their door. It's a little bit more understood. So that's where we've originated. And when you talk about in the warehouse, what it means to us, a sensor manufacturer and automation, you understand that it provides uptime improvements. It provides a level of automation to the complexity of the systems today, because as we discussed, they're getting more complex when you talk about applications in a warehouse in material handling. And then also the efficiency of it. Those are three of the main things, I think, that make IIoT in the warehouse attractive.
So, of course, we have to break this down to our sensors. We're a sensor manufacturer. Yes. We want to do that. So let's talk about, just name a sensor that you think we should be discussing in light of these three improvement areas.
Yeah, it's a good question. There's quite a few that come in my head. So I think initially I often talk about the vibration sensor.
Great. So why is vibration critical, and how does that fit? What type of offering do we have?
So with vibration, I think the main one, we have a few, but the one that I think is pertinent to IIoT in the warehouse and material handling, I would say would be the IO-Link version of it. So the idea is you're measuring what is happening on the conveyor based on the motor. So you understand if it's vibrating or such, right? And you can utilize that data.
So anything where you have motion could potentially have vibration.
Absolutely.
And you're saying, if I monitor that, if I take a time series data, then I can derive intelligence as to this is going to get critical.
Yes, and let me be clear. Some vibration is normal. So we're not just saying, hey, it vibrated, that's a problem. You have some parameters, right? The user has some parameters of what is normal, what is not. That's them. We provide that data. And then they can take that data from there and say, hey, this is outside of the norm. But that vibration sensor will give you the data to make that necessary. It enables it.
Yeah. So as always, we're not claiming that we know more about an application than our customers
Definitely
do.
Not.
They can do that. We're the enabler of this improvement.
We provide the data.
That's vibration. What's another one, you think?
So another one that's a little more on the photoelectric side of things and LiDAR based would be what we call the Contour 2D. So basically what it is belt utilization. It's looking down over a conveyor to understand the efficiency of the conveyor.
Explain that, because I think we've done an episode about the Contour 2D some time ago, but I think it's worthwhile to summarize again what it does.
Gladly. So what it does is it's one LiDAR sensor, 2D, that looks down over the conveyor. And it's got, a computer that reads the data of what it's scanning. So if you have, 4 or 5 boxes coming down your conveyor belt, it'll tell you a number of things based on the scan as it passes by the layer of LiDAR. It'll tell you, the height, the width, and then most importantly, the percentage of the belt that's being utilized.
Okay. So in a nutshell, what that means is if I have a big conveyor, expensive conveyor, and I have a box every hour, I'm not really utilizing it too much.
Precisely. So it's a data collection tool. And honestly, that's one of the summaries of most of the things I'm talking about here. It's a data collection tool to understand what's happening over time. So you can have the ability with a dashboard to understand trend analysis. In this case, with the Contour 2D and belt utilization, we're understanding how much of the belt is being used. Is that efficient? Is that what you want? Sure, if you've got a 4-foot wide conveyor and you're only using 2% of it, that's your business. But at least you have that concrete data to make the decision.
And you could take that information and design a new access point to the conveyor because you can move more over that conveyor highway.
The options are unlimited, in my opinion.
Yeah.
What we do is provide the data to let you make an informed decision.
Very good. One more.
So after that, I would say a little bit more simple would be a photoelectric sensor. I think most in material handling in that realm, they're probably pretty familiar with it, right? A lot of times it's for presence, right? Hey, is a box there or not? But also, or detection, but also measurement is another one too. And measurement is critical because when you look at it like that, I think you and I talked about the example of knowing whether a person's there. That's one thing, but knowing how far they're away, that's an extra bit of data that is provided from the sensor that we provide through IO-Link to understand what's happening over time. Because if you have something that's there and you know how far it should be away, maybe you have some tolerance or a threshold, but it starts to, migrate outside of that. What does that mean?
Yeah, maybe the mounting bracket got loosened up, or maybe a bearing is no longer as tight as it should be. So it's again, it boils down to, I understand you that we're not telling you this is a problem.
Nope.
We're giving you the tools.
Precisely.
We're giving our customers the tools to make this intelligent decision based on the data.
Exactly. And that's honestly the common denominator out of all three of those: the vibration, the belt utilization, and the photoelectric. We give you the data to make you ask why, right?
Yeah.
What it is, sure, you'll find that out, but we give you the data so you can say what happened here.
And there's one other thing that I know I should add on the photoelectrics, and that is with our IO-Link sensors, there's some internal diagnostics data we can provide. So we measure temperature, and also we provide a signal that identifies the quality of the returned light. So a photoelectric sensor works by sending and receiving light, and if you create too much dust on the lens, that signal is degrading.
Absolutely.
And over time, that could lead to a shutdown.
Absolutely. And again, that's looking at the trend analysis over time. Maybe you have a dashboard that's created, but it's with the data that sensor just provided, as you just detailed.
Yeah.
Having that ability.
You briefly talked about complexity.
Yes.
And the need to help operators work more efficiently. How do specifically IO-Link sensors, for instance, how do they help our customers that need to run a machine as long as possible, as efficient as possible, to do exactly that? Yeah.
So one of the fears, I think, that maybe, or concerns, maybe a better term, that people have when we talk of IIoT, predictive, preventative maintenance, these terms, is the complexity of it. And part of this conversation is to make people understand that the sensors that we provide with the data that it enables you makes it less complex. Because you have, maybe for a real example, a maintenance guy who has a conveyor that has multiple sensors on it. Does he need to be the expert on each one of these complex sensors?
Can't be.
He can't be. I can't be. Nobody can be. You don't have to be. That's the key. Some level of it is automated with IO-Link, with some of those features that you talked about. So now when they look at the trend analysis and say, hey, we need to replace that sensor, you don't need to understand how to program it. You don't need to get in the software to get it to where the replacement sensor was. When you plug it in and replace it, it's automatically configured. Yep. That's the first thing that's a huge advantage, right? Takes stress off of the maintenance person, the replacement guy.
No more screwdriver to make adjustments. No more dip switches. No more pre-configuration. IO-Link masters do that for the user. That's very powerful.
But there's another thing too. So in addition, okay, you don't have to be in the software trying to understand it, but also, how do you know it's the right one? Some of these things start blending in, right? Looking the same. What is that the right one? When you put it in, you also have the ability, maybe through a dashboard, to say, is that the right sensor or not? And have an indicator of, whoops, that's the wrong one. Another part of the automation that you don't have to be an expert on. Yeah. Big advantage.
Yeah, that's great, because IO-Link sensors are communicating. One of the key parameters or key data points they are communicating is, I am this type of product.
Right.
So now you can make a comparison.
That's
say,
right.
nah,
Doesn't match.
You're not the right one.
That's right.
Go away.
But that, again, makes it easier for the user because they don't have to be this expert on all of these sensors. That's daunting, and it's also not necessary.
Yeah. So now we provide the data.
Mm-hmm.
We don't do the analysis.
That's correct. So one of the things, again, and this is to draw some clarity on some of these topics, because who's doing what, I think, is part of the question, right? We provide the data that will go to a higher level system with maybe our partners that can manage that. And what that means is we give, like the example with the vibration sensor, we provide the vibration sensor that has the data that will enable the cloud partners to take it, create a dashboard based on their customer specifications, their thresholds, what they care about, a simplistic number, and go from there. It's kind of like, I think you and I talked about it, your oil. When you're driving your car, right? Do you know when it's time to change your oil? Maybe back in the day, it was based on a certain amount of mileage. That was very general. It was fine, but it wasn't as accurate as what we have today when it tells you, hey, you need to change the oil. You know what that means? There's a sensor under the hood somewhere that I'm not that familiar with that is giving some type of data to the overall vehicle to tell you exactly when you need to change your oil. Now we're more efficient.
Yeah, exactly. You're not doing it just because it's January, and you're not doing it just because you drove 5,000 miles. All of these are very, very coarse and unsophisticated indicators.
And that becomes inefficient. And you know what that is? That example you just said, what we just discussed, is predictive and preventative maintenance. That's what it is. Instead of having scheduled maintenance, right? There's downsides to that. Sure, that's an advantage over what was done before based on just a feeling. But it's not ideal as an understanding. Say, hey, look, every quarter we're going to replace that sensor. We're going to create some downtime. Maybe that works out, but maybe it's not ideal, because if you end up replacing a sensor that was just fine and you stop the line,
wasteful.
That's wasteful. Now we're giving you the data to make you a lot less wasteful. That's why we keep using the term efficiency. The sensor will tell you when it's time to do it, just like the car tells you when it's time to do the oil change.
Excellent. Jerry, I think we need to wrap this up. You know the drill.
Yes.
Think about a 5-word statement, what we want our audience to take away. And in the meantime, while you do that, I'm going to try to summarize what I've learned today from our conversation. And you tell me where I'm off.
Okay.
So Pepperl+Fuchs provides sensors with a lot of additional information that can be used in IoT applications to increase the efficiencies. We talked about vibration sensors, gave an example. We talked about our Contour 2D, which measures belt utilization as something useful for material handling. And we went into a little bit of detail with our photoelectrics, where we not only talked about things like signal quality and temperature, but also expanding the notion of what does it mean to see an object, where in the past we may have just detected something is there or not. Now we measure the distance, we turn that into a there or not signal, but we also provide information about mechanical aspects of this. And you brought up a great example with the oil life indicators on cars. I think that's very instructive. Under the hood, something is measured in some strange way that we don't care about ultimately.
Or maybe don't even understand.
And it's turned into, you have 76% oil life left. And that's the number that is critical. So
that I understand.
Preventative and predictive maintenance is going to be even more important, because it reduces cost, not just by not doing things that are unnecessary, but also doing things that are necessary at the right time.
Well said.
Good. All right. Thank you. So 5 words.
Yeah. And you're kind of creating it as we're going along. And I think the overall, message that we're saying here is that P&F provides the data for IIoT. That's it. Is that 6? That's 5 words or 6 words?
We scratched the and it's fine.
That's the gist of it, though.
Very good. Jerry, as always, I appreciate your time. Thank you very much for sharing this with us, and I hope the audience get something out of it. And they can always reach Jerry Pacey, of course.
Absolutely. Welcome to it, and appreciate your time, Helga. It was a great conversation. Hope it was useful.
Thank you very much, everybody. Thanks for listening to Pepperl+Fuchs Plugged In, and we will be back soon. Bye-bye.
Bye.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.